Hi, welcome to Python 10. This is a special episode on defining your own functions. We have made it to the end of the Python series. This is the last video that you will need to watch in order to understand everything you need to know for first year laboratories. So, let's begin. Here we are. So, we're going to be covering why to use a function and how to make a function as well. So, to start off, code can become repetitive. Printing graphs again and again, huge novels of code being cloned to perform the same job, scrolling up and down to change every detail, it's just not good enough. So why should we use a function? Well, functions are most useful for repetitive bits of code. We can simply type the code out once and call the function to run the code again as many times as we want. This saves us copy and pasting and filling our screen with a load of rubbish, quite frankly. So for our purposes, every replica of plotting a graph contains the same code, but there are different parameters every time that we need to manually input. So scanning lines for parameters to change can become quite tiring. I've got some of this rubbish code that you might copy and paste a bunch of times down below here. I want you to note all the places that have unique information. So let's look here, let's scan down the lines. Where does unique information show up? That is, unique to the file that you're plotting, the columns, what it is you're doing, what you want to call things. So to start off, the first unique thing is the name of your file, the file name. Then we've got the X column name, the Y column name. They're unique as well. You could have time in here. It could be something else that you've got. And then down here, there's nothing unique in polyfit. There's nothing unique in here because we're using variable names. We don't need to input anything here. These things aren't unique. They're just telling you the results of polyfit. This is just y equals mx plus c. Plot the figure. That could maybe be unique if you want to change it, but it's pretty much the same every time. The x label, that is unique. You want to call the x label whatever it is you're plotting. So what you're plotting is going to be different. It could be time in here. It could be position. It could be distance. So that is a unique piece of information, the X label. Another unique piece of information down here is the Y label. So you're going to have a different thing on your Y-axis. You're going to have different units. So you want to change the name of that. That's another unique bit of information. And another bit of unique information is the title of your graph as well. Then down here, this is pretty bog standard, no unique information here. Maybe you don't want a grid, maybe you do want a grid. That could be classed as unique. Making the graph, plotting the scatter plot, that's not entirely unique either. Let's see, the file name, saving the file name of the image, that is unique. You might want to save it as, you'd want to save it as something that you can identify it by. So that's a unique bit of information as well. So from all of these things, there's unique information. You might think, how can I use a function? I need to change my parameters. I need to change these every time. Well, you do, but not by scrolling and clicking. No. Simply enter your parameters as the inputs to your function. So remember, things like our keywords such as def and ending the function heading with a colon as well when you're defining a function. Additionally, the function body also needs to be indented too. So let's see in action. We are defining our function here. This is what it looks like, this bit here. So up the top, I've got what's called the function header. I'm using the def keyword to show that I'm now defining a function. I've got my function name. We're calling it plot linear graph because it only does one job. It's only going to plot a linear graph because we've coded y equals mx plus c into the behavior of the function. Now here, I've done something, and you can actually do it differently. I've listed all the parameter names vertically down the ways. And the reason I can do that is because as long as I've got a rounded bracket up the top here, and then commas between every variable name, and then a rounded bracket down the bottom at the end of all this list, and I finish it off with a colon, Python knows that these are all variables. They're all variables in the function name. It doesn't think they're individual lines of code. No. It knows that these are variable names. All you need to make sure is that they're indented, I suppose. In fact, you might not even need to make sure of that. Well, they do need to be in the function body, actually. But another way to have them done is you can also just have them up the top here along horizontally in a big list. But I just thought it would be clearer for you to understand it if I put it vertically down the ways so you can see each description of what they do and what they are. So our parameter names are pretty straightforward. We've got a CSV name, that's the name of our file. The x-axis, that's the column name of the x-axis. The y-axis, the column name of the y-axis it's from your CSV file, that is what that'll be. And all these things are strings as well. We've got the title next, and then the x label, the y label, and finally the image name as well. So all the parameters here all take a string. They're all in the form of a string. And down below we've got the code. And you'll notice that wherever we had unique information before, I have replaced that with the parameter name that now holds that unique information. So when we're doing pandas.readCSV, I've replaced it with the parameter CSV name. And that means that whatever value is held in CSV name will now be used in that function call. So that's a really smart thing, and it's really great that functions do this, and this is why we use them. So again, in the x-axis, for the x, I've used this variable, I've used the y-axis variable. Where else have I used it? I've used it in the x label, the y label, the title, and I've used it in the image name as well. So the values that are held in these variables can be used in the function. And what's good is that these variables only exist inside of the function as well. We call this the scope of the variables. We say the scope of all of these variables, all these parameter variables, they're in the local scope. The local scope of this function. This means that they actually don't exist outside of the function. So I could not call CSV name outside. I couldn't say print CSV outside of the function body because CSV name would not have been defined. After the function stops executing the code, all of the variables before are destroyed. They're removed. They don't exist anymore in the memory. So all of these variable names only apply to what's inside the function. So you can have variable names that are the same as what's outside. Just as long, you can pass, obviously, variables into your parameters. And that'll mean that the parameter is actually that variable, so the value is just passed on. But these only exist inside the function. So we can call it now, and I'm showing you how you can write it out horizontally here. This is how you write it horizontally. And you can write it vertically as well. And when I do this, it's going to print it out twice. Oh, sorry. I need to execute this so I can define the function first. So now the function's defined, and now I can call it as a relevant function. So it says, here in the error, name plot linear graph is not defined. So it says, this function doesn't exist. I don't know what you're telling me to do. Now I've defined it. It does know what it's doing. So when I call these two lines, what it does is it jumps into the function body, it executes all of this code and places in the values in these parameters into here, executes the code, and then returns the function. It stops. And then because I've called it twice here, we're going to have two graphs. But you can see it's worked. It's worked. We've got our gradient. It's just the same from the gravity CSV you remember from ages ago. So it's done it twice. We can call it, if you prefer to call it horizontally, you can do that. Vertically takes up more space, but maybe you prefer to do it that way in the right order. I usually just call them horizontally. Works for me. Less effort. So that's an example. So if you want to get quick graphs in your labs, just define a function at the start. Write out your code once, have a function, bring that function into each of your new notebooks, and you can have a graph made like this in seconds. Literally just the press of a button like this. Boom, there you go, graph right there. Now, the thing is, your function behavior is limited. You might need to have different functions for different things. It's not very flexible. We couldn't, for example, plot a graph with multiple lines, or plot a graph with a Gaussian filter or rolling average filter. So what some programmers do is they break down code into smaller functions so that they can piece together to have a larger functionality. So it's like making a graph of some kind. Maybe you want to make a graph of some kind, you've broken down your graph function into smaller functionalities so that you can place, it's very customizable. You can place functions together to make your own graph. It's a bit like Lego with functions. That's what it is. That's exactly what it is. It's up to you now. This is the end of the Python series. It's now up to you. You can be creative with your approach from now on. There are still lots of things in Python for you to discover. You won't need them for this stage of your degree, but who knows what will come next. So a list here in a sensible order of discovery of these new things. So first, I would recommend you start with conditional statements. These are things that are like true or false. So if you say, is this variable equal to the length, or is banana true? Next up is a while loop as well. So that is, while this condition is true, perform this loop. When it becomes false, stop the loop. There are also dictionaries as well. These are a type of data structure. So lists were ordered data structures and we could index them with numbers. Dictionaries can hold anything in their sort of indexing value, anything in their key, and then they hold values as well. So you can learn about them. Next up is error checking as well. So maybe you want to make sure that the parameter for one of your functions is a string. And so you're able to add in code that will do that. And after that, you might want to go into algorithms. So there are algorithms for searching a list, sorting a list, sorting your data sets. So this could be useful for later on in your career. And you'll learn about sort of big O notation and how it's sort of mathematically and logically impossible to sort things faster than a certain number. And n log n is about the fastest sort you can do if you know some information. After that, you might want to go into classes and objects. So this is like object-oriented programming. So when I was telling you about the figures and the axes in Matplotlib, that was a bit of objects. So they had characteristics and we could call some functions on them as well. You remember the append function for list? Well, that function can only be called on that class, the list class. And then after that, you might want to get into multi-dimensional arrays. That's maybe more useful for advanced programming, advanced analysis of data. And after that, maybe you might want to touch on dynamic programming, which is really useful for optimizing different things. So an example would be, say you're buying some train tickets, to get to university, and you want to know what train tickets should you buy if you're traveling for 3 months. What's the cheapest train ticket that you can buy? Maybe you're traveling a sort of awkward number of days and you want to find out, is it cheaper for me to buy, a 7-day ticket or 2 28-day tickets? And so you would use dynamic programming for this to optimize your problem and find out what's the best solution by comparing all of them. But dynamic programming reduces the runtime of that, because that would be a pretty big runtime to try every single option. So that's it. Thank you very much for watching. I hope this Python series has proved useful to you. We appreciate any feedback in the comments below on what you found useful. So keep it civil, but we appreciate them. That's all for me. Good luck for next year. Good luck for this year. Good luck for the rest of your years. Up next, nothing more from me. Bye.